A very good evening, everyone. I'm the Slima Safrin, student of King's College of Engineering. A warm welcome to all the esteemed guests, respected speakers, and faculty member. Our beloved principal, Dr. J.R.P.APPAVU ma'am, joining us for day 2 of the 5 days international faculty program on revolutionizing education with machine learning and generative AI. Yesterday, we embarked on the insightful journey exploring the integration of AI and machine learning in education with Dr. M. Brinda ma'am. Today, we take another exciting step forwarding us delve deeper into the fundamentals of machine learning, a topic that forms the backbone of AI-driven innovations. The future belongs to those who believe in the beauty of their dreams. Now I invite Ms. S. Abikal Arti ma'am, Assistant Professor of King's College of Engineering, to deliver the inaugural address.
Good evening to all the participants. It's my great pleasure to invite and welcome our Dr. Appavu Life Balamurugan Subramanian sir, who is a professor in Periyar Maniamma Institute of Science and Technology. Sir has done a very great work in the literature review and most number of cited journals in more number of journals. Sir has having a cited by 184 in the literature review on feature selection method for high dimensional data. It's a great pleasure to have you in this platform, sir. And we are happy to have you in the busy schedule. You are accepting us and doing a great role for us. Thank you, sir. And the session is yours.
Very good evening to everyone. It's a matter of honor and privilege for me to be with all of you in this evening to give the overall idea about the technology or the topic chosen by King's College of Engineering. I think it's a very potential and emerging topic in the era of artificial intelligence and machine learning. I really appreciate the Department of Computer Science for selecting this particular topic, where you relate the kind of stuff on both artificial intelligence, machine learning with generative AI, right? I hope it's a kind of very interesting topic for the at least next 20 years. The people are majorly going to talk about this particular area of AI as well as generative artificial intelligence. And at the juncture, I would like to extend my thanks to the coordinator and convener of this program of King's College of Engineering for providing me and the kind of this opportunity to at least discuss my idea. And I hope it's not the kind of seminar where I'm going to talk about how the different ML and generative AI stuff are applied in the domain of educations. But however, I hope that this is a platform where I try to share my past experience related to the different field in the area of AI and ML that's suggested by your friend Aarti madam. And madam clearly pointed out when you see my previous research, where you can see that most of the contributions are related to the domain of AI, machine learning and data science. And when you see the topic of my discussion, I am focused more on providing the kind of fundamental knowledge in the field of machine learning. However, the broad area of this particular seminar is focused more on how to apply the kind of ML and generative AI stuff to the problem of educational domains. I hope really you are enjoying this particular session and will get some insight about how to understand the basic terminology that related to the domain of AI and machine learning. So before going to start my presentations, so I would like to share my personal experience about where I started my career and what are the different area where I worked previously in the past 20 years. And I hope I try to connect the dot between the vertical domain in the area of AI, machine learning and data science to the faculty as well as student, those who are attending this particular workshop. So when you see the career of I began my research in the year 2003 when I worked at the Tyagaraja College of Engineering, and I remember I enrolled my PhD in the area of data mining. And that time I focused more on developing the kind of data mining algorithms to solve any kind of real world problem in the domain of data mining. And later I came to know that most of my PhD work rely on developing the kind of theoretical research in the field of data mining rather than applying the domain of data mining to the different vertical. I focused more on how to develop the kind of theoretical research in the area of data mining. And I started my PhD about how to apply the data mining stuff to the domain of network security and information security. Even so, most of you know that the attack on the World Trade Center in the year 2001 led to the permanent effect of the United States and the rest of the entire world. So, in order to avoid such a disaster in future, the effective security system need to be established. When you see how the data mining related to the particular problem of cyber security, and after the attack of the World Trade Center, I came to know that the main root cause of the particular problem is the kind of exchanging information between the different terrorist communities. But the CBI, FAI and other federal agencies are failed to identify the possible meaning of those emails. But however, as part of my PhD work, I just extended how the data mining applied to the step of classifying those email into the several categories. Say like, so the email is either in the category of normal or in the category of suspicious, or the email in the form of terrorist email, right? Hope everyone know that this is the kind of binary classification problem where the data mining expected to provide the kind of solutions to these particular problems. And I applied the variety of data mining algorithm in this particular context, and I get the kind of binary classification to classify the incoming email into the two different categories. Either is a spam email, not spam, is a normal email, or kind of terrorist emails. So what was the problem I faced during the data collection is I rely almost on the primary data, right? Because that is very difficult to collect the data from any repository which talk about how the real terrorist email is look like. So I faced a lot of problems in that case. So I couldn't be able to collect the kind of synthetic data, right? Because when you see the history of the data science or the ML, where you can see after 2024, the people are talking about generative artificial intelligence. So which is very capable to generate the kind of synthetic data. So as in the case of when you face the problem of data collections in the real world scenarios. So that is not the case during my PhD in the year 2003. So I collected all the email sample through the mechanism that is called as a synthetic data collections, for which I approach the different people, they are working in the different organizations, and I asked them to write the data which reflect the scenario of terrorist email. But later I feel that data mining is also useless in this particular domain, because data mining is only look at the content of emails in the data. But when you see the most realistic terrorist email is something like some known agent Al Qaeda will send a bomb to the destination airport. But there is a coded word between the email that are exchanged between the different terrorist community. So which is really difficult for both the AML and data mining algorithm to identify the meaning of those email data. I think it's a challenging for any kind of AML stuff, because AML is only able to identify the meaning of the explicit email that are exchanged between the different terrorist communities. So I thought of why not we inherit the property from the other domains like network securities or information securities. So what I would like to say is there are the cases where machine learning or data science stuff is alone not help you, where you need to integrate the different technology together. So this is the reason most of the time I'm telling that there is a kind of overlap between the different technology, as in the case of computer science and engineering. Even when you see the history of computer science and engineering, right, I cannot separate AI, ML, data science or data mining. So still I can see the kind of overlap between the different terminology. Say for example, data mining and ML, data science, big data analytics, predictive technology, and generative AI. These are the kind of subset as in the domain of artificial intelligence. This is my understanding on AI. And so when you see the today agenda of today's discussion, I'm going to talk about a little bit on the very basic fundamental principle of artificial intelligence and what are all the research challenges and the opportunities in the domain of AI. And I'm going to talk about something on the concept of machine learning Then I'm going to talk about something on what are the research challenges and the opportunities in the domain of machine learning. And if time permit, I'm going to talk a little bit about how the both AML stuff are applied to the two different vertical use cases. So firstly, I'm going to talk about something on the behavioral analytics. I think it's a very, very interesting topic for you, where I'm going to talk about how the data science and ML and AM stuff are applied in the domain of behavioral analytics. Then, if time permit, I'm going to talk about something on employee attrition predictions. I consider this is the kind of educational data where I'm going to discuss about how the ML stuff is applied to predict the employee attrition in the effective way. Finally, I'm going to touch a little bit on what is the responsible artificial intelligence and machine learning in the context of generative and normal AI, and what are the explainable artificial intelligence and ethical AI, and how do you relate it during the deployment of any of your AML project. That is the today agenda of my discussions. And hope everyone know the underlying theory of artificial intelligence, where is evolved and what are the different vertical algorithms as in the case of artificial intelligence, right? So when I talk about the artificial intelligence, I always feel that the field was evolved in the year 1940. So most of you know about there is a kind of expert system that is I think is a first kind of AI system that was introduced in the year 1970. So which is represents the kind of medical expert system which is capable to identify the disease pattern actually in the effective way. That was introduced in the year 1980 and the year 1988. And that expert system is referred as a MySyn, and this is the kind of both the knowledge-based system and the expert system that related to the healthcare domains. That expert system is capable to identify the disease pattern. I think it's a kind of classification problem and prediction problem as in the case of machine learnings. And later you can see there are a lot of challenges or changes in the domain of artificial intelligence. Say for example, when you see the classification of AI system, so basically you can see the three different classifications of AI system. So the first is referred as a narrow AI, and type 2 is referred as a super AI. And what is the second types? Anyone? Can you help me? What are the three type of AI? Participant, kindly help me to identify the three type of AI systems. I request everyone, please be interactive, right? Right. I mentioned very clearly that is not kind of one-way communications. I expect the kind of interaction from the audience because I'm going to talk about only my personal experience and things I have done in the past 20 years in the era of AI and machine learnings. Can anyone, what are the types of AI? Narrow and super AI, right? But when is the history after 2025, the classification is suddenly changed. The people are classified the AI system into the two different categories. The category one is called as normal AI, and category two is said to be the generative artificial intelligence, right? So when you see the other kind of subset of artificial intelligence, where I always claim that the AI is a kind of mother, where machine learning, data mining, data science, deep learning, and all other stuff related to the AI, like big data analytics and predictive technology, are referred as a kind of subset, right? So AI is a kind of umbrella terminology where all the other terminology are said to be the subset. But the classification of AI system is suddenly changed after the year 2015. So when you 2 years before the AI, there are two different kind of classification according to the industry standard. The first classification is referred as a kind of cloud AI, and the second type is referred as a kind of edge artificial intelligence. Hope everyone know what is the cloud and edge AI, right? Whereas in the case of the cloud AI, we have to collect the data with the help of different devices, and you have to store the data in the cloud server where you have to deploy your AI, ML or data analytics model. But as in the case of the edge AI, you have to deploy your model directly on the device where you have to perform the learning, and the decision making also happen in the device rather than performing the kind of learning in the cloud environment. That is not the case in edge artificial intelligence. So when you see the industry, current industry scenario, most of the application they are make use of edge artificial intelligence rather than the cloud AI. I think it's a kind of shift from the cloud AI to the edge artificial intelligence in the AI eras. But the entire scenario has changed after the year 2014 because of invention of the generative artificial intelligence, right? Again, there are two classifications as in the case of AI system. The first classification is referred as the general AI, and the second classification is referred as the kind of generative artificial intelligence. I hope this generative artificial intelligence is one of the dominating and influencing area as in the case of the computer science engineering, at least for next 20 years. So the reason is very simple. When you see the power of generative artificial intelligence, there are a lot of ethical applications where you are able to apply the stuff of this particular generative artificial intelligence. So coming back to the history of my PhD work, and between the year 2006 to 2009, I focused more on improvising the performance of the different machine learning algorithms. Even when you see my publication area, you can able to understand that along with the several collaborators and few students in the Thanjavur College of Engineering, I focus more on how to identify the kind of exception in the field of the variety of machine learning algorithms. Even 2009, along with my supervisor, I have developed the kind of my first major theoretical contribution in the field of machine learning, that is referred as ID6NB, where I just extended the problem that part of the traditional decision tree index algorithm, and I renamed that algorithm as ID6NB. So where I handle the problem of majority voting failure in the conventional decision tree index algorithm. And that work has been cited in the Wikipedia in the year 2009 as one of the most significant contribution in the field of machine learning research. Because when you see the previous history, where you can see that there are a lot of variety of decision tree index algorithm, and each algorithm is a part of the classification data mining, and most of the algorithms are developed by the different authors from the different countries. But I very proud to say that I am the only Indian author who made the kind of very good theoretical contribution in the field of improvising the performance of decision tree index algorithm in the year 2009. And later I focus more on other kind of machine learning algorithm. So particularly I most interested on identifying what are all the short part in the problem of naive Bayesian classifier, right? Hope most of you are aware of naive Bayesian classifier, which is a kind of supervised learning algorithm in the context of machine learning, right? So which is based on the principle of probability theory, where we have to calculate both the prior and the posterior probabilities. So I have identified some shortfall in the conventional naive Bayesian algorithm, where as in the case where we are getting the equal prior and posterior probability, this problem is referred as the kind of tie breaking in the naive Bayesian classifier. So as part of my research work, I have provided the kind of solution to handle the problem of this tie breaking in the naive Bayesian classifier. And I renamed this work as a NB plus, that was cited in the Wikipedia in the year 2009. Again, one of the most significant contribution in the field of machine learning research. So why I'm telling this particular point is that most of the researchers, those who are working in the area of AML, they focus more on applying the data mining and machine learning stuff to the different vertical applications. They are not focused more on how to apply it, how to deal the theoretical issues that is part of any AML system. That is very, very essential, I think. And when you see the history of the big data that was introduced in the year 2012, big data was evolved. Previously, the data size is up to, right, terabyte or the petabyte, where we feel that the conventional database management system can able to withstand up to the terabyte. What happened in the IT industry after the 2008 is data size had double, triple between the year 2002 or 2009 is similar to the Moore law of central processing unit speed. And the people assume that the data collected from the different sources or from the social media and different type of data are evolved in the IT industry after the year 2012. So what happened in the conventional database management system is not capable to store the data in the effective way. That is why the big data was evolved after the year 2012 in the IT industry. And one of the effective big data analytics framework was developed by, right, Yahoo, that is referred as Hadoop. Hope everyone know what is Hadoop. There is a kind of distributed framework that is really capable to store the data of any types. That was introduced after the year 2012. Right? So, guys, when we talk about the AI, right? So, most of you have different understanding on what is the actual definition of artificial intelligence, right? Even I have my own definition on it. I always say AI is, right, a study of how to make the computer to think in which at the moment the people are better than computer. But I always feel that, right, human being is always better than the computer. I also always assume that the computer is a kind of stupid machine comparing with the human intelligence, because we have the love, we have the emotions, we have the common sense, we have the understanding of different scenarios, right? Again, often you are getting confusion that then what makes the difference between the computer and the human being as in the context of artificial intelligence, right? And I think it's a very interesting topic when you compare the human being along with the computer is a separate, I think it's a separate kind of brainstorming discussion, right? That is not required in this particular contest. Audience, how many of you from faculty? Aarti madam, kindly help me. How many of you are faculties and how many are students attending this workshop?
All of us practical, sir.
Most of you are faculty, right?
Faculty. Yes, sir. Yes, sir.
Okay. Great, madam. Thank you. Right. So again, when you see the history of artificial intelligence, right? So we have the four different capability for any AI systems, right? Can anyone help me? What are the four capabilities applicable to any artificial intelligence system? Can anyone kindly help me? What are the four capability of any AI systems? According to the industry standard, there are four capabilities that are applicable to the any AI system. The first capability is think humanly. The second capability is referred as think rationally, and third one is act humanly, and the final one is act rationally. I will repeat again for your better understanding. Think humanly, think rationally, act humanly, and act rationally. Can anyone help me? Are you able to list out any AI system at present that able to fulfill all the four capabilities that I coined? Anyone of you? Kindly help me. I will repeat the question again. Are you ever seen any AI system at present that is really capable to fulfill all the four capabilities that I mentioned? Because this is the capability expected from the industry for any AI system. While deploying any AI system in the market, this is what the industry expected from the developer. But so when you look at the capability of any AI system, right? Most of the AI system are capable to fulfill only one capability, according to my understanding. That capability is think humanly, not think rationally, but act humanly, right? Most of the AI system act similar to the human. Very great example is robotic system or any kind of machines. Whatever the instruction given by the user, the machine is able to follow it, right? So when you see the capability, the current AI system is not able to fulfill the other three capability that is expected from the AI system. Say like think humanly. I hope no AI system is available in the market that think similar to the humans. That not exist, right? Think rationally, right? That is another challenging area that is expected from any AI system, because rational thinking is very difficult task. Say for example, I am asking you the question. So what basis you are attending this particular workshop, and what are the factors that you are considering, or why you are working in this particular institution as a faculty, right? So where you have to apply your rationality, right? And you have a lot of choices where you have to apply your scenario and you have to identify which choices work better for me, right? Rational thinking is very difficult actually, because you may provided with lot of choices and lot of opportunity, where identifying the particular choice or particular opportunity is very challenging even for the human being. But when you assume how the AI can be able to achieve it, very difficult actually. But how do you achieve it? With the help of the kind of computational approach, right? Say for example, the people are talking about the kind of optimization algorithm as in the context of artificial intelligence, right? Hope most of you are aware of the various optimization algorithm that are available in the AI, like, right? PSO or genetic algorithm or MCDM, right? Hope everyone aware of what is the MCDM, right? Multi-criteria decision making, where the people are talk about AHP and TOPSIS. These are the kind of effective computational approach which really help you to make the kind of rational decision. But still, the field is not yet mature actually. What is the fourth capability? Act rationally. That is very, very challenging actually. I think no AI system is right available which able to fulfill all the four capability. But I personally feel that ChatGPT can able to fulfill three capability that is suggested by the industry standard, but not all the four capability. Now the point is, when we expect any kind of AI system that will able to fulfill all the four capability, we may expect such kind of AI system in the year 2050. That is why that AI system will be referred as a kind of super artificial intelligence, where we expect the AI try to replace all the human being in most of the cases. Say for example, right, all the seminar presentation will be done by the AI system rather than the expert, and no political parties in the any countries. AI will lead the entire government, and most of the governance structure will be formed by the government structure will be formed by the kind of AI system rather than the humans. That is what we are expecting in the year 2050. That is referred as the kind of super artificial intelligence, right? When you see that, when you compare AI, machine learning, and deep learning, and even generative artificial intelligence, I always feel that there is a kind of overlap, right? But most of you misunderstand what is the underlying relationship between the AI, ML, and deep learning and data science and even data mining, right? Still, I feel that there is a both all the technology are utilized interchangeably, right? Can anyone help me? What is interchangeability? It's not the kind of mutually exclusive, right? Say for example, I want to deploy the AI model on any particular application. Say for example, in the case of educational domains, right? What I really need, I want the support from the different technology. Say for example, some idea I have to get it from the ML, and some idea I will try to get from the deep learning, and some idea from the data science, and some idea from the generative AI. So that is why I refer is a kind of overlapping, right? It's not interchangeable, right? It's not the kind of interchangeable. So when you see the history of artificial intelligence, machine learning, and the deep learning, so hope everyone know the machine learning is popular, right? Most of you understand that machine learning is popular after 2010, right? But I always saying that the statement is totally wrong, right? Because when you see the history of machine learning, where you can understand that the first machine learning model was actually introduced in the year 1940 in the field of financial domains, right? Where the expert apply the machine learning algorithm on the credit card analysis data set actually, where in that case he interested to classify the customer into the two category, whether he is eligible to get the card or not, right? So the point is the first ML model is applied on the kind of data set that is referred as a customer data set. Is particularly talk about credit card analysis that was introduced in the 1940s. And hope everyone aware of what is the deep learning and how is differ from the machine learning, right? So as in the case of the machine learning algorithm, so we rely mostly on the data, right? Data is a fundamental, right? Say like if you ask a question to me, without data, can I work with the machine learning algorithm? Obviously, my answer is no, right? Because data is a most essential element for any machine learning algorithm. Without the data, we are not able to work with any kind of machine learning algorithm. But when you compare the machine learning along with the deep learning, you can see that machine learning, the feature selection is one of the fundamental requirement, but that is not the case for the deep learning algorithm, because the deep learning is trying to mimic the behavior of the biological brains. So that is the reason most of the deep learning algorithms are derive the property from the conventional kind of neural network architecture. Say like most of you are aware of what are the traditional kind of neural network architecture, say like perceptron learning or artificial neural network, CNN, and right? And people now talk about the GAN and autoencoder, so on. So this is the kind of powerful deep learning model as in the context of artificial intelligence. So Yes. So when you see the major difference between the deep learning and machine learning, so basically there are two major steps are executed as in the case of any machine learning algorithm. The first step is feature selection or attribute selections, and second step is right model deployment or algorithm selection, followed by the deployment of model and model evaluations. But as in the case of the deep learning, no feature selection is required, right? Straight away you go to deploy your model on data set, and the model can able to make the kind of predictions or the forecasting or classification on the selected data. So now I'm going to talk about a little bit on what is the historical context of machine learnings. Guys, much of what you know in physical sciences had their origin in astronomy with the observation of celestial objects. Thanks to Herculean effort of pioneers, thanks to Galileo, thanks to Newton, thanks to Kepler. These are not among the other in the field of physical sciences. It's also estimated that the amount of data collected double in every 3 years. Amount of data collected double in every 3 years. Thanks to computers, thanks to large scale storage devices, and also thanks to sensor technologies. When you see the application of the machine learning, right today, machine learning is almost applied on the different vertical domains. Say for example, machine learning is applied on the physical sciences, biological sciences, engineering sciences, medicines, and government at all levels. So hope most of you know about the Gaussian, right? And he is a mathematician and statistician. And when he was only the 12 years old, he developed the first machine learning model in 17th century. Now we are living in the era of 21st century, right? So we always believe that the machine learning or the data science or deep learning was introduced in the year after 2000, right? But the statement is totally wrong. When you see the history of ML or AI, you can see that the concept of machine learning was introduced 400 years before actually. So where you can see that the first machine learning model was introduced in 17th century by Gaussian. So the point is very, very interesting. When he was only the 12 years old, by knowing the known model of his time and other object, he identified what is the underlying principle behind any object with the help of the instrument that is called as telescope. So he developed a kind of assimilated model. That model helps you to identify what is the reappearance, or it really help you to identify any kind of missing object with the help of the instrument that is called as a telescope. Based on the model and observation, he developed the first assimilated model in 17th century. That assimilated model is considered as a first kind of model in the field of machine learning research, right? So what I'm trying to say is the first machine learning model was introduced in the 17th century by the Gaussians. And this invention may lead to the development of another technology in the field of machine learning that is referred as normal distribution. Hope everyone know about what is a normal distribution, right? This particular distribution was introduced by the Gaussian in 17th century, right? So when you see the structure of any normal distribution, is something like bell curve, where most of the population are lie in the mean areas, and remaining population are lie in the left and right side of the curve, right? So according to the industry standard, right, average where you can see the 50% of the population, even you consider any organization, where the 50% of the employee are average performer, and left side of the curve saying that remaining 15% of the employer or 15 to 20% of the employer are low performer, and right side of the curve saying that remaining 20% of the employer are the kind of top performer. That is what the bells say. This particular curve is introduced by the Gaussians. So the point is, this particular normal distribution and bell curve is again one of the method as part of the unsupervised learning in the context of machine learning, right? Hope those who are doing the research in machine learning, you can understand that this normal distribution and bell curve also lead to the development of another terminology as in the case of unsupervised learning, that is called as method of least square. This method of least square is one of the performance evaluation metric as part of any kind of unsupervised learning algorithm in the context of machine learning.
Sir?
Yes.
Sorry to disturb you, sir. Sir, actually we cannot able to see the slides, sir. It's chopped in first slide, sir.
Oh, not able to see the slide?
Yeah.
Okay. Are you able to see now, sir?
Yeah, sir. Now it's
sorry, sir. Really sorry for it.
Yeah, thank you.
Thanks for the information.
Thank you.
Thanks for the information.
Yeah, thank you.
And right, data is collected from the different sources, right? You know, right? Many companies, organization, and research project are collect the large volume of data, right? Say, for example, we know that data collected from the different sources, one side from social media or sensor or different areas. Say, like most of you talk about transactional data, right? Assume you are running your mall or the supermarket where you are dealing with a different customer, wherein you try to collect the data from the different sources, and which I talk about the transactional history of the different customer in the context of association rule mining. Hope this association rule mining is one of the interesting part, as in the case of the data mining research, not related to the machine learning. And you also talk about the agriculture data, where you place a sensor in the different field, and those sensors are capable to collect the data from the different region, where I say the edge artificial intelligence is most, right, really good in this particular context, rather than rely on the cloud artificial intelligence, while you deploy the kind of AI or ML stuff in the agriculture areas. But I'm not going to talk in this particular area much, right? So when you see the machine learning, theoretically, you can understand that the machine learning is a kind of interactive process, right? So when you see what are all the process followed in any machine learning algorithm, you can see that there are sequence of steps followed in any machine learning algorithm, starting from problem identifications, attribute selections, identifying any suitable machine learning algorithms, and learning, followed by model generation, model deployment, and final step is called model evaluations, right? So why I say the data mining is machine learning is a kind of interactive process, because there is a kind of relationship where you can see between the different process, as in the context of machine learning. Say, like, you consider the data collection process, right, in the context of machine learning. So basically there are two approaches with reference to the industry standard. The first approach is called as primary data collections, right? The second approach is referred as a secondary data collection. So as in the case of the primary data collections, what we are supposed to do is we try to make the kind of interaction with the different stakeholder, and you have to develop your own Google form or any questionnaires, and you go to the field area where you have to make the kind of detailed interact with the different customer or sometimes with the stakeholder and collect all the data related to your project. That is very, very interesting, right? That is basically represents the kind of primary data analysis, where you have to conduct the kind of interviews or group discussion or sometimes the brainstorm session, where you invite the different expert or the domain expert and make the kind of interaction and collect the data that relate to your project. That is the one way. That is basically represents the kind of primary data collections. And there is another way that is called as a secondary data collection, where you try to collect the data from the different data repository. Sometimes you refer the website or you refer the journal article or textbook, so on and so. But what industry say is, so you mostly you try to work with the primary data collections. Assume you are the kind of person you want to work in the industry rather than academia. What is expected from the industry is, right, mostly you should try to do the primary data collection rather than secondary, right? Because what is required as in the context of machine learning is you are capable to make the kind of interaction with the client and what is the various requirement by the client and how to pick the different devices or sensor unit in the field area, and even sometimes how to develop the data set, right? How to develop the kind of questionnaires that related to the task is a really interesting part. And hope everyone know that what is the output of applying machine learning algorithm on the any data set, right? This may be the audio, video, image, or text, whatever it is. The output is basically the model, right? We almost expected to generate the model while deploying any ML algorithm on the data set, right? The output is always a model, right? This is what expecting from the any machine learning algorithm. But what will happen in the real time scenario is after deriving the kind of model, applying the variety of machine learning algorithm, sometimes we feel that the model performance is not good actually. Right? We expected that the model performance is 90% or sometimes 100%, but model perform poor in most of the data set, right? You deploy on the model on several data set. So the problem may be the data that you are collected is not good actually, right? Maybe the one reason, or you collect only the limited data, right? When you see the industry standard for the machine learning, the standard says larger the data, lesser the error, or lower the data, the error is high, as in the context of machine learning research, right? So what is really required is you try to collect the large volume of data if you want to really deploy the ML algorithm on your different use cases, right? But I feel personally that there are the case where it's very difficult to collect the data because, right, data collection is really very challenging. Say for example, in my previous example, I mentioned that if I ask you to write the email which reflect the context of terrorists, I think it's really challenging for each and every one of you because we are not the kind of terrorists. We are not able to write how the actual terrorist email is look like, right? Even when I did my PhD, I faced a lot of problem to generate the kind of synthetic data. But now I hope the generative AI help you. With the help of generative artificial intelligence, you are able to write your own synthetic data which mimic how the actual terrorist email is look like, right? Thanks again to the generative artificial intelligence. That is a very interesting part. Then, so another point is that when data pre-processing is very interesting, right? Not only interesting, is very essential for any machine learning algorithm because the survey says when you see the industry standard, 90% of the time and effort is only applied on the data cleaning part rather than deploying your data mining or machine learning algorithm on the data, right? The reason is very simple because there is no quality data, there is no quality results, right? Because the quality of the result is fully depends on the quality of the data set is used for the experimentations. Guys, those who are doing the research in machine learning or data science, my personal suggestion is that you focus more on this particular area. The area is called as the data pre-processing, where you try to develop the kind of different stuff and deal how the different data issues that right affect the performance of the variety of machine learning algorithm. This part is very interesting. Even when I worked with the Agricultural Engineering College in the year 2010, I received the grant from the UGC for executing this particular project, where I was interested to understand the different property of the several machine learning algorithm as in the context of learning from inconsistent and conflicting data, right? So where the problem is arise actually is, assume you are the kind of machine learning researcher and assume you are doing the research, theoretical research in the field of machine learning. Most of you assume that assume you are getting the misclassification while deploying your machine learning algorithm on any data set. What you are assume in the most of the cases is that the misclassification is happened only due to the machine learning algorithm. But when you see the real case is something different. The misclassification is not only happened by the machine learning algorithm, it's also happened by the quality of the data set used for the experimentation. So what is the point here is you try to develop effective data quality checking algorithm or the method before going to deploy your data mining algorithm. That is very essential as in the context of the machine learning research. So when we talk about the attribute and scale in the context of the machine learning.
Sir, sorry to
Yes,
interrupt,
madam.
sir. Kindly look on the slide, sir. Yeah.
Madam, are you able to see the slide?
I can able to see the slide, but yet it's not moving. It's yeah, sir. From the beginning.
Now, madam, is moving, madam.
Data collection in the real world, it's showing, sir. Yeah.
Now is moving attribute selections.
No, sir.
I am projecting attribute selection, madam. Is it moving?
No, sir. Share that PPT, sir. Share the PPT, sir. PPT screen.
Madam, are you able to see that attribute selections?
Yes, sir. Attribute selection. Now it's yes, sir. Now I can.
Madam, challenges
yes,
in data ML. Are you able to see that?
No, sir. No.
Challenges. Not able to see that. Now,
no, sir. Sir, may I suggest, sir? Go with the F5, sir. Go with the F5. in the sharing part, you select that particular window, sir.
Now, madam, what is the title you are seeing, madam? Now,
Now also I can able to see the attribute selection.
but I hope you are only seeing slideshow window only. F5. Is it, madam, now?
No, sir, you have to share that FI, no? FI screen window.
Now?
Attribute selection, sir.
Yes. Next slide, madam. Are you able to see that?
No, sir.
Wait for just 1 minute.
Okay, okay, sir. Okay, sir.
Are you able to see that, madam? Aarti, madam, are you able to see that? Can anyone help me? Are you able to see that slide?
No, sir.
No, sir, no.
Not able to see that. Anything?
Yes, sir.
Aarti, madam, are you able to see the slide?
Yes, sir, it's an attribute selection.
Great, madam. Okay. So, coming back to the point of attribute selections, hope everyone know that what the fundamental idea behind attribute selection, right? So, where we try to look at what are all the contributing attribute for our machine learning model, right? And again, attribute selection is a very challenging and the basic fundamental requirement for any machine learning algorithms. where we try to pick up the right attribute for the task, right? Particularly when you hope most of you work in the domain of healthcare analytics, right? By applying the different AML stuff, where I hope the attribute selection is going to play the major role, because when you look at the data structure of healthcare and other different domain, where you can see that the healthcare data is mostly talk about attribute selections rather than other terminology, because where you can see that lot of million to billion of attribute, particularly when you refer the website of Henrich Biomedical Data Repository, which talk about the data related to the different domains, particularly the cancer, where you can see the different dimensions. Even some of the data set are having higher dimension of million to billion of attribute or the columns, right? Wherein identifying the right attribute is very, very challenging. Even as in the case of cancer, prediction is very difficult to identify what are all the gene patterns that may lead to the problem of cancer, right? So manual approach is really not helpful in this particular context. So we have to refer the computational approach, that is basically referred as attribute selection in the context of machine learning, right? So where initially we have this much of right column in our data set. After reduction, we try to reduce in the number of right minimal columns. That is the purpose of attribute selections. So when you see the history, we can see that basically there are three objectives that are applicable to any attribute selection method. The first approach is reducing the number of initial attribute. Then we try to reduce the computational complexities, and is also try to improve the predictive performance of any machine learning algorithms. Hope some of you are doing research in the area of attribute selections. I think there are a lot of opportunity that are available in the context of attribute selection if you are doing research in the area of machine learning, right? If you are the kind of person, those who are working in the area of the deep learning and generative AI, I hope the attribute selection is not applicable in this particular context, because both the generative AI and deep learning algorithm is capable to identify the suitable attribute from the data set. There is no specific approach applicable in the context of deep learning and any kind of generative artificial intelligence algorithms. Madam, are you able to see the next slide? Challenges. Aarti madam?
Sir, am I audible?
Yes madam. Major challenges in the data mining. Are you able to see that?
No, sir.
No, sir.
Attribute selection only.
No, sir, your slide is not rolling, sir.
Suppose sir,
No.
nothing, sir.
No
Actually,
madam. Now are you able to see that?
no, sir. Attribute selection. Sir, in the share the presentation, by doing the share the presentation, you click the particular window, sir. Don't select that PPT, sir.
Wait madam. Now madam, are you able to see that?
Yes, sir. Now I can able to see the challenges.
Now visible, sir.
Now visible, right? Now
Yeah.
another slide, right?
Yes, sir. Machine learning yesterday. Yeah.
Okay, great madam.
Yes.
So guys, this is a very important part for you, I think actually. The major challenges in the data mining, right? And even the context of ML and artificial intelligence. The first challenge may be the data size. Hope everyone know the size of the data is grow more than linear, and which is similar to the more speed of central processing unit speed, right? And we are getting the data from the different sources that I mentioned previously. And the second challenge is the data complexities, right? Because the different type of data are available nowadays: audio, video, image, text, right? And the curse of dimensionality that affect most of the machine learning algorithm, because right previously the dimensionality is very less actually. Say like most of the work in the algorithm of KN, right? Is one of the supervised learning algorithm in the context of machine learning, where we try to compare both the training and test record. We try to identify who are all the nearest neighbor for the given test record. Where what is the major problem is for the given test record, sometimes you may see the n number of training example will be considered as a nearest neighbor. In that case, again the problem of dimensionality reduction will happen actually, right? So assume that you are dealing with a million of rows, right? You deploy the kind of KNN algorithm on this particular data set. For the given test record, what is expected in the KNN algorithm is you need to identify who are all the nearest neighbor for the given test record, right? In the given million of training data, it's very difficult to identify who are all the nearest neighbor for this particular case. That is basically referred as dimensional reduction in the context of machine learning. And third problem is the curse of dimensionality. So which talk about the column size, right? So learning from the large column is always very difficult actually. Say, I would like to give the very simple example. You are the person who are interested in the domain of climate change predictions, where you try to apply the different machine learning algorithm, right? You guys, we know that basically there are three variables that related to any weather prediction system. The variable may be the temperature, humidity, and windy. Now the question is, which variable is the most influencing variable as in the context of weather prediction, whether if you want to identify whether there is a chance of rainy or not, or Sania Misra will play tennis at King's College of Engineering or not. Again, it's a kind of prediction problem where we refer the different kind of classification or sometimes the prediction ML algorithm to identify appropriate answer for this particular case. But what is the major problem here is picking the right attribute or identify the most suitable attribute in this particular case is again very, very challenging, right? So when you refer the theory of attribute selections, basically there are three approaches you can see. The first approach is a filter, and second approach is a wrapper, and the third approach is embedded in the context of machine learning, right? But scenario is different in the context of deep learning and generative AI. There is no dedicated algorithm is required to perform any effective attribute selection method. Even when you see my publications previously, so along with the collaborator, I have done a lot of work in the area of attribute selections, where I developed the kind of various machine learning stuff, and some of the algorithm are the black box in nature. So my algorithm are really capable to identify or pick only the relevant attribute from the large data sets. And third challenges in the machine learning is the data quality, because you guys know that, right? We are collecting the data from the real world. Obviously, there is a chance of messy and tattery, right? There is a chance of noisy or error in this particular data set. And moreover, most of the times, the noisy information comes from the measuring instrument. Assume you are the kind of person working in the hospital where you are responsible for the collecting the data from the different instrument, and sometimes you are not aware of what is the underlying principle behind each and every machine, right? Sometimes you are the good in the computational part, but you are not having any kind of knowledge about how to deal with the different instrument. So obviously, whatever the data you are collecting, there is a chance of error or misclassification or missing value. So that is the third challenges as in the context of machine learning, that is referred as the data quality challenges. So I feel personally that all the three challenges are right will be considered as a kind of separate research work in the field of data mining. And madam, are you able to see now?
Yes, sir. Yes, sir. It's
Today, right?
Yes, sir. Yes, sir.
Okay, good, madam. I think those who are doing the research, if you want to do the kind of theoretical research in the field of machine learning, that is very, very interesting, right? So after COVID-19, I realized that there are previously I understand that there is only one symptoms that associated with any disease, right? But personally, after COVID-19, I realized that one symptom may be associated with several number of diseases. Say, for example, before COVID-19, what was my assumption is that there is a symptom called, right, body pain, right? I say, in that case, I say the body pain is related to the disease that is called as a fever. But after COVID-19, what happened in the industries, right? The body pain, that also another symptom for the COVID-19, right? So when you look at the 100 years ago, right, one object is associated with only one class, right? I am referring the target variable, right? One object is associated with only one class. When you look at 50 years ago, same one object is associated with the two class, but now the scenario is entirely different, right? When you see the current scenario, where you can see that one particular instance may be associated with n number of classes or n number of target label or the class label, right? Say for example, if I ask the question to you, right, how many languages you are familiar, right? So I say I know Tamil and English. So where the class label are not the kind of single, is a kind of binary or sometimes it's a multi-label. It's referred as a multi-label in the context of machine learning. Say for example, I would like to give a very simple example. Assume there is a record, right? The first record where you can see, right, A comma B, where A comma B implies C. That is the first record. There is a second record where you can see that same A comma B implies D, where C comma D are talk about the different disease. So say like A comma B implies fever, that is the first record says. A comma B implies COVID-19, that is what the second record says, right? But when you see the history, here you can see that both, even though both the record is talk about the same predictor, but the different class label. Assume you deploy your machine learning algorithm on this particular data set. What happened is the machine learning algorithm cannot make the kind of predictions where you can see the kind of misclassification from the data. So I think this is the part of work that I carried out while I pursued my postdoctoral research in IIT Roorkee in the year 2020 actually. So I focus more on two different areas. So one is how to deal with the different multi-label data set, right? So this is possibly not the case before the year 2019 because most of the data are available in the form of single label, right? So after 2019, the industry realized that most of the instances of the data set are, right, having the kind of multi-label where if you deploy the kind of traditional ML algorithm, you cannot able to expect the appropriate or right result actually. Sometimes you get the kind of misclassification or performance error, right? So what is the point here is, if you are the kind of person, those who are like to love the research on theoretical research on the machine learning, I feel this is the kind of very good research topic for you. So what is required is you have to do the lot of studies on what is the multi-label problem in the context of machine learning and what are the traditional method available and what kind of contribution you are supposed to do, right? Even as part of my postdoctoral research at IIT Roorkee, so I have developed one more machine learning algorithm that I named as AVD, that is called as Attribute Value Dependent Classifier, right? And I proved that this particular classifier are well suited where the attributes are highly dependent actually. So my assumption is that I assume that it is expected that all the attributes are highly dependent on each other, right? So accordingly, I developed this particular algorithm that is called as Attribute Value Dependent Classifier. So when you ask what is the specialty of this particular classifier comparing with all other traditional machine learning algorithm is that instead of looking at the correlation between the predictor and class label, I look at what are all the values that present in the predictive attribute and I just relate the value of the predictor along with the class label or the target. This is the way this particular classifier is work. If time permit, you go search in the Google and refer. That is referred as the AVD, that is Attribute Value Dependent Classifier. So what I am trying to say in this particular context is you try to do the kind of theoretical innovation in the field of machine learning, right? So the point is you try to develop the kind of new machine learning algorithms similar to the classifier that are available in the literature. Hope everyone know about what are the different variety of classifier available in the context of machine learning, right? Coming to the next point, I'm going to talk about something on what are the challenges and opportunity for ML expert, right? So say like if you ask a question to me, right? Sir, I'm doing the research on climate change artificial intelligence, right? Where I'm going to deal with both text data and the kind of image data, right? If you ask a question to me, which machine learning algorithm is well suited for this particular problem, right? Guys, I'm not having any specific answer to this particular question because when you see the literature of machine learning, there is no catalog is available which help you to identify or ensure that which machine learning algorithm perform better for the given data set. Again, it fully depends on the data set that used for the experimentation and the underlying principle behind each and every machine learning algorithm. The point is there is no catalog at all. So most of you guide the student in the area of machine learning, right? If the student asks you the questions, sir, can you suggest which ML algorithm is suitable for my use cases, my applications, right? You suggest that there is no right? There is no catalog in that case actually. So what is really required in this particular context is that you try to apply the several machine learning algorithm for the given use cases. Say for example, you are doing the climate AI, right? How the ML is applied in the domain of climate AI, right? Assume you are the kind of person working on the text data rather than image, right? What was the problem in the text data is you are not able to get accurate result as in the context of climate modeling, right? Because when you see the underlying relationship between the variable in the context of climate modeling, where you can see lot of interconnection, right? If you deploy the kind of ML algorithm, you are not able to make the accurate predictions. That is the reason the researcher also referring the satellite data, right? The point is they are not only considering the text data, say like what is the temperature of the particular day or what is the humidity and what is the windy of the particular day. They also collect the data from the satellite image, right? If you refer both text and image data, I feel that the conventional ML algorithm is totally useless in this particular context. Any guess? Because if you want to do the analysis from the satellite data, I hope that you may refer the kind of deep learning algorithm. Particularly, you rely on the kind of CNN algorithm because surveys is CNN is one of the most powerful algorithm, as in the case of most of the image classification applications. But what is the problem in the climate modeling is that, right? Say for example, I'm asking you to told with the apply the different ML algorithm on the climate data. What you are supposed to do is you have to look at the historical data, right? Right? Please understand that most of the ML algorithm are based on the historical data, which is also called as training data, as in the context of machine learning, right? So in the context of the machine learning, the historical data is talk about the past history. Say like what is the climate condition from the year 2000 to 2025? That is basically referred as a historical data and the training data in the context of machine learning, right? I ask you to generate the kind of synthetic data for the year 2025 to the year 2050, right? I cannot say this particular data as a kind of historical or the past data because the data is talk about the climate condition of 2025 to 2050, right? How do you achieve it? I hope the generative AI will help you in this particular context. So what is possible with the help of generative AI is you are able to generate your synthetic data that talk about the climate conditions from the year 25 to 2050. That data you consider the kind of training data or the past data where you try to apply different ML stuff instead of considering the data collected from the year 2000 to 2025 as a primary data. So the point is one framework with many variation is very, very essential for any ML research, right? Don't stick on with any specific algorithm while deploying the ML algorithm in specific applications. The second point is that try to understand the power of each algorithm. Guys, this is very important for you. Because if you want to become a very good expert in the ML, what is expected is you should possess the capability where you are able to differentiate what is the underlying principle behind each and every ML algorithm, right? That is very, very essential. Then you try to solve everything mathematically. That is very, very essential, right? You try to solve everything mathematically. Very, very fundamental tool for any machine learning research. Because as if you are the kind of ML expert, right? Most of the time it is expected that you are going to work with a different domain expert. Sometimes you may work with the doctors, right? In that case, you should aware of what are the terminology that related to the medical domain. Sometimes you may expect that to work with the electrical people. They are talking about the data from the grid, or sometimes you may work with the electronics engineer. They talk about the data from sensor or IoT devices or other stuff. Sometimes you may work with the management guys. They talk about the business data, or they talk about the transactional data and so on. So sometimes you make with climate change and sustainability, where understanding the domain knowledge is very, very essential, right? So in that case, you are not supposed to claim that I'm only the machine learning expert. I'm not having, or even sometimes I'm not possess the knowledge in the various vertical domain, right? That capability, that also very, very important, right? That is the reason most of the time I'm telling that the machine learning is not the engineering part. It's not the kind of technology is only the science or art. Even sometime when your mother looking at your pattern during the childhood period, I refer is the machine learning, it's not the technology. And when the policeman looking at the structure of the crime data or doctor looking at the structure of health data, everyone is considered as the kind of machine learning approach, right? But in the context of the machine learning, we have to refer the dedicated algorithm like supervised or unsupervised or sometimes the semi-supervised learning algorithm, right? Previously, I mentioned very clear that when you see the history of the machine learning, you can see that, right? This particular context, I would like to thank, right, Alan Turing. Hope everyone know the Alan Turing is the first man who, right, provided a lot of stuff in the domain of machine learning, right? Even the first work on machine learning was coined by Alan Turing in the year 1915. And he raises a question whether the machine think similar to the human being. This is the first question raised by the Alan Turing the year 1950, where I hope the machine learning was evolved in the entire IT industries. So when you see the historical context of machine learning, I always assume that the machine learning is a not new field, right, which was evolved in 1940, where the machine learning applied in the domain of financial cases. So hope most of you get the confusion that what is the difference between the machine learning and the data mining, right? Even sometime I personally, right, feel that what is the overlap between the machine learning and data mining, but there is a kind of again overlap. So whatever the terminology that discussed in the year 1980, between the year 1980 to 1999, the terminology was coined as data mining or sometimes the computational statistics. So after the year 2010, the data mining was replaced and named as a kind of machine learning. Even when you see the syllabus of any leading universities 20 years before, the particular title or the subject named as data mining or the kind of computational statistics. Now the data mining is replaced and named as the machine learning. Still, I feel that both machine learning and data mining is almost refer the same terminology, except there is algorithm in the data mining that is called as association rule mining that is not part of any machine learning context. And the recent availability of the huge volume of data along with the development of data mining, machine learning and right big data provide a lot of stuff in the IT industries. And hope you know that recently the available computational tool for many applications are inadequate. That is the reason why the scientists need the better computational tool. They enable them to follow the new rule and new logic that support both multidisciplinary and interdisciplinary research and also support right the kind of machine learning stuff in the era of artificial intelligence. When you see the history, we are limited with the very minimal number of computational tools as in the case of machine learning. Even I would like to share my personal experience. When I started my PhD in the year 2003, virtually everyone was using the MATLAB as a kind of stuff to execute the various data analytics process. But you guys know that there is a problem in the MATLAB. So because the MATLAB is a kind of commercial tool, the cost is around 15 lakhs to 20 lakhs. So what happened in the industry is that they thought of replacing the MATLAB with other kind of conventional tool. That is the reason why in the year 2006, Java was introduced in the IT industry, and the people assumed that to replace the MATLAB by the kind of Java, so and so. But personally, I always feel that and still feel that there is a thing where MATLAB is still superior than the kind of Java or Orange or Python, so and so, right? So those guys who are working good in the Java, they focus more on developing the kind of machine learning stuff in the year 2009 and 2010. That is one of the most leading machine learning tool was introduced in the year 2006 by one of the universities in Netherlands that is referred as the Vega. Hope everyone aware of what is the Vega. Is a kind of machine learning tool. Again, it's an open source which help you to work with a different ML algorithm, but without understanding the functionality of various ML model. Again, the Vega is an open source, but fully Java based, not based on the Python programming. But what is the problem in the Vega is a kind of clicking button, you can able to see the result, but you are not able to understand what is the underlying principle behind each and every data mining or machine learning algorithm. Again, it's a kind of black box method, right? You are only able to see the result without understanding the underlying principle, right? And when you see the history after 2010, R become popular in the IT industries. Hope everyone know about R. Is a kind of statistical tool, and R replaced both Java and right MATLAB as a kind of stuck to the machine learning and data science research. But what was the problem in the R is that hope everyone knows that R is a open source. But still, there is a challenges in the R programming is that you cannot able to automate the entire process. Assume you are the kind of industry expert or industry person where you want to deploy the kind of ML or AI model to your customer or end user. If you apply the kind of R programming in your data set, obviously you cannot able to automate the entire process. Assume you want to deploy your model to the client or customer, you need to install the R programming in the client machines. I think it's very not feasible in most of the cases, right? But however, if you want to do the kind of theoretical research where you want to analyze how well the performance of the different ML algorithm, I say the R is a very good choice. But if you want to deploy any kind of ML model, or if you want to develop any product for the industry, R is not a good choice. That is why the Python was introduced. Even replaced the R as a programming language of choice for data mining and data science research in the year 2006. Right now, the industry says Python almost displays all the conventional programming language like R, Orange, or Vega, or Pythons, or Java, as in the case of most of the data science problems. Even most of the industry, they rely on the Python programming because the reason is very simple, right? If you want to develop the kind of prototypes, I feel the Python is a very good choice, right? There are a lot of functionality that offered by the Python to develop your model in the effective ways, right? But still, if you feel the data size does not matter, right? It's not only the problem you are going to apply the Vega or Orange or other kind of stuff. And one more problem is the scalability, right? The people are talking about the scalability. We talk about the size of the data. Again, is a very, very challenging. Even when I started my PhD, we make use of the GPU, right? Graphical processing unit. Later, now the technology is evolved. The people are talking about edge artificial intelligence rather than the cloud, where it is expected to work on the another processing unit that is called as the TPU. Hope everyone knows that. That is a tensor processing unit. That is a kind of processing unit that is applicable to the most of the edge artificial intelligence. Even when you see the industry standard, you know, the NVIDIA and Yahoo and different vertical industry, they focus more on the kind of edge artificial intelligence rather than cloud AI. But where the challenging part is that to dump the quantum of data in any particular data repository, where I hope this tensor processing unit are going to play the major role. Even you guys know about the different variety of tool available under Pythons like TensorFlow or Keras or PyTorch or Scikit-learn. These are the kind of open source library that is offered by the machine learning. Most of the library are rely on both the kind of GPU and tensor processing unit, right? So you should possess a kind of capability to work with the different recent ML tool. That is very, very essential if you want to do any kind of project or interesting research. You should possess the knowledge on the TensorFlow and Keras. When you see the industry standard, most of the large scale project, they make use of the TensorFlow, right? Guys, have any one of you having good knowledge in the TensorFlows and the Keras? You have the very good opportunity in the field of AI/ML. And if anyone having the knowledge in the generative AI, definitely you have the kind of very good opportunity for the next 20 years. Even the survey says, whatever the technology I am talking to you, we are discussing about the machine learning, right? The literature says sometimes the machine learning will be replaced by the generative AI, because the literature says machine learning is not part of the generative AI, it's part of the general, it's part of the traditional artificial intelligence. But however, I feel that this machine learning is anyhow the fundamental for whatever the technology that they are going to study in the context of generative artificial intelligence, right? And guys, most of you getting the confusion that what makes the difference between machine learning and the traditional computer programming, right? And I think it's a very, very interesting part. As in the case of the computer programming, so what you are supposed to do is we have the set of input, right? Then we have to, right? We have the set of physical formula or mathematical formula or mathematical procedure, right? And we can generate the kind of output. This is what the case in the traditional computer programming. So where we have the set of input and instructions. So based on that, we have to generate the result. But how the machine learning is differ from the kind of traditional computer program is that, as in the case of the machine learning, we have the input and the kind of output, right? We give both input and output as an input to the computers, and the computer can able to identify what is the physical formula or what is underlying relations, right? Say for example, I would like to sell very simple example in the context. If I ask you to convert the temperature into Fahrenheit, I think it's a very simple problem. The problem is converting the temperature into Fahrenheit. If you are applying the traditional computer programming, what you are supposed to do is you have to give what is the value per temperature in Celsius as an input, and what is the physical formula to convert those Celsius into Fahrenheit, and what is the expected output is where you can see the temperature in the form of Fahrenheit. But in the case of the machine learning, what is the input? We give the temperature in Celsius as an input, and also the same temperature in Fahrenheit as another input. Then we try to identify what is the association between two different input. This is basically referred as the model in the context of the machine learning, right? So where we try to interconnect two different input together and we try to generate the model. That is not the case in the traditional programming, right? And another interesting part is that how the human being and computer make the decisions. Say for example, I ask you to instruct the student or the small child to understand or to identify or to differentiate the different object. Can anyone help me? What is your approach in this particular contest? Anyone kindly help me? The question is, you are instructed to, right? You are requested to give the kind of instruction to the child to differentiate or identify the different object. So in the context of simplification, I say the object is a fruit actually. What is your approach? Anyone of you? Kindly help me. The question is, what is your approach to provide the kind of intelligence to the small child, 2 years or 3 years, to differentiate the variety of object. Object may be the different fruit. We consider the type of object or apple or orange or bananas. How do you provide the kind of intelligence? So the point is that firstly I try to show what are the different objects. I show how the banana is look like. I will show how the apple is look like. I also how the oranges look like, right? And I also inform the child is that this is a shape of the apple and this is the size of the apple and this is a color of the particular object or color of the object. So what are the things I refer to the child? Firstly, I will explain how this particular object is, right, referring, and secondly, I have to explain whatever the variable that is part of that particular object, right? So later, what the child is supposed to do, when the child, when he or she see the unknown object, he is able to identify those objects into the several category, like is a kind of apple or orange. Now the question is whether the child can able to differentiate it through experience or right, by referring the kind of explicit programming. Can anyone, what is your thought process in this contest? I am asking the audience. Anyone help me? The question is whether the child is identify the object through experience or by referring the explicit programming. Guys, as in the context of the machine learning, right?
By experience, sir.
Very good, sir. Great. You are great, actually. The child understand only through the experience, not looking at the kind of instruction, right? This is how the human being is different from the computer. But as in the context of the machine learning, the algorithm not understand the pattern by referring the experience. It's only understand the pattern by referring the kind of data. This is how the machine understand the pattern and how the human being understand the same pattern. right? Human being can able to understand the pattern only through experience, but the machine can only able to understand the same pattern by doing the kind of analysis with the help of data. That is the reason most of the cases, right, we are not able to get the better result in while applying or deploying any machine learning model, right? This is the reason people say when you deploy the artificial neural network to any data set, obviously you are getting better result because this particular classifier mimic the behavior of the biological brains. Is can do lot of iterations until reach the goal state, right? That is the reasons most of the application, the artificial neural network is expected to give the better result than all other kind of data mining algorithms. I think it's a very, very fundamental. I'm not going to discuss more on this particular part, right? So the point is, based on the data, the machine can able to understand the different patterns, but that is not the case for the humans. And so hope everyone able to differentiate what is the traditional program and machine learning is different actually, right? Machine learning, we try to generate the kind of model that is not the case in the most of the traditional computer programs. And I want to talk a little bit about the variety of machine learning algorithms that are available at present and what are the challenges associated with each algorithm, right? Hope everyone know that these are the three broad category of machine learning algorithm. One is a supervised learning, and the second is unsupervised learning, and third one is a reinforcement learning, right? When you see the supervised learning, again there are 5 to 6 classifications, right? Say like decision tree, support vector machine, KNN, Bayesian, artificial neural network, and so on, so right. So hope everyone know that decision tree is a very fundamental algorithm in the machine learning, which look like the tree structure where the tree is something like we have the root node and intermediate node and terminating node, so on, so right. Hope if you want to do the research in the particular decision tree, I think it's very, very interesting for you because the tree structure is really easy to understand, right? And it's not the kind of black box method, right? There are a lot of scope in that particular area. But this particular classifier is based on the principle that is called as information gain and entropy. Guys, I'm not going to talk more on what is the underlying principle behind the decision tree because I have restricted with the time and I'm going to discuss only on what is what in this particular context, right? And the second classifier is called as Bayesian classifier. So this is based on the probability theory where we have to calculate the both prior and posterior probabilities, right? This particular classifier was introduced by the Bayes, and hope everyone know Bayes is also known as the Bayesian classifier. And one of the major problem in this particular classifier is that this classifier assumes that all the attributes are independent of each other, right? All the attributes are independent of each other. But when you see the real world data, we cannot expect this particular principle. Say for example, when you see the weather data where we can see that 3 different kind of attributes, say like humidity, temperature and windy, right? Now I ask the question to you whether all the attributes are independent or dependent. You may give the answer that all the attributes are always dependent actually. But this particular author assumes that all the attributes in the real world are independent of each other. But when you see the real world data set, we cannot expect always the data are highly independent of each other. That is why this particular classifier is referred as naive. Naive meaning is the useless, or in the Tamil meaning is alpam actually. But other assumed all the real world attributes are independent of each other. But real world data we cannot expect it. That is the reasons most of the real world application this particular classifier is not suited actually, unless otherwise your data are highly independent of each other, right? And the third approach, the classifier is called as the KNN. Again, is a kind of powerful algorithm, but again is referred as a kind of lazy learner algorithm. Why is referred as the lazy learner? In the Tamil, lazy learner is a somberi. Why is referred as the lazy learner is that is not does not generate any model unlike other machine learning algorithm. So whatever the test data you are able to find out the class level by referring the kind of training example, right? And this is referred as a kind of lazy learner. There are basically the two approaches as in the case of the KNN classifier. The first approach is called as pairwise comparison and second approach is called as using the Euclidean distance as a method. And other classifier is a SVM. Hope everyone know that SVM is a kind of most powerful ML algorithms because it's applicable to both the kind of linear and non-linear data classifications, right? And what is the underlying principle behind the SVM is where it try to draw the hyperplane that able to differentiate both negative and positive example together. So finally, artificial neural network again is a kind of very interesting and most powerful algorithm in the context of machine learning because this particular algorithm try to mimic the behavior of the biological brain. When you see the history of ANN, the first algorithm referred as perceptron and the second algorithm is called as backpropagation neural network. There are a lot of other kind of deep learning algorithm are considered as part of ANN, particularly CNN and RNN and SOM. And now the people are talking about GAN and autoencoder. These are considered as the kind of generative artificial intelligence algorithm. But however, everything is considered as the family of artificial neural network algorithm. If you ask a question to me, I want to become the kind of expert in the generative artificial intelligence. What is the fundamental requirement is you should possess the kind of thorough knowledge or skill in the area of neural network. That is a very, very essential. Rather than understanding the kind of other data or machine learning algorithm. So you have to do the thorough research or study on how the traditional neural network algorithm are used in the different contexts. Then it's very easy for you to apply generative artificial intelligence in the different context. Guys, if you want to do the kind of research in the climate AI, so you have a lot of opportunity in these particular domains. Previously, I mentioned that the climate data is very, very challenging to identify what are the influencing variables in the case of climate AI. And guys, there is a forum is available that is called as Climate Change AI. That particular forum is run by one of the leading expert, and I think Professor Priya, and that madam is working in MIT US, and she is working as assistant professor in the area of computer science, and he is also the founder of this Climate Change AI, where you are able to get the different material and information related to the workshop, seminar, and variety of conference in the field of how the AI and machine learning applied on the domain of the climate change. If possible, you refer through Google and enroll in this particular forum. I think it's very really interesting, where you can able to see that how the different ML algorithm or the stuff are deployed in the domain of climate change data. Right? Those who are going to enroll your PhD, I may consider this is a very interesting and challenging topic for you. And I'm not going to concentrate more on this particular topic and is talk about almost the basic part, right? And hope everyone aware of how the classification algorithm is working. So we have the data where we apply the ML algorithms, algorithm perform the kind of learning and generate the model, right? And then we have to evaluate the performance of the model, where we try to ensure that how well the performance of the generated model, where we have to refer the various measures. Say, as in the case of the classification ML, we have the four performance metrics, say like accuracies, precision, recall, and F1 score. So these particular metrics help you to identify how well the performance of your generated model. So once you evaluate it, sometimes you feel that the performance of the model is not good or satisfactory. What you are supposed to do is you have to collect the large data, or you have to try to resolve the problem of data pre-processing, or sometimes you have to fine tune the performance of the model in the different ways. So these are the kind of various stuff which help you to further improve the performance of the model, right? And I discuss about what are the variety of kind of algorithm in the case of classification, the machine learning. Now this particular presentation will focus more on the regressions, right? So everyone able to differentiate how the classification and regression are differ in the context of machine learning, right? So classification, so idea is that given a collection of object and record, the process of classifying each object into one of the several predefined category based on the record value. So we have the object on one side and variable on the other side, where we try to interconnect both object and variable together, right? Whenever the new or incoming object is coming in the context, So which try to refer the both predictor and target. Accordingly, we have to assign the label for the given test record or the new sample. But regression is completely different, where we try to connect both independent and dependent variable together. Assume you are the kind of marketing person, you want to ensure that how the marketing campaign will able to improve the able to improve the sales values. Sales, hope everyone know that there is a mall in Thanjavur, right? That mall is opened by one of the actors, I think is Kirti Thurais, right? So where I think the owner of the mall spend a lot of money towards that particular campaign or marketing strategies. Now you are the kind of machine learning expert. You should ask the question whether this particular marketing campaign or marketing strategy really improved the sales performance. How do you find out that with the help of ML stuff? The answer will be provided with the help of regression model, where you try to collect the both independent and dependent variables, right? So where you try to identify what are all the underlying relationship between the two different variables. Say like I would like to sell one more similar example. The usage of the power pattern in the home. You guys assume that the power utility almost determined by the temperature of the particular days or the climate condition of the particular day. But when you deploy the kind of regression model, you are able to find that temperature alone is not the kind of dependent variable as in the case of climate modeling, or to identify what is the what is the consumer utility pattern of the current values. That is a very, very challenging. So what is really required is you have to work with a different kind of regression model. You may refer the kind of linear regressions if you deal with only one independent or kind of the dependent variable. If you deal with more than one independent and dependent variable, you have to go along with multiple linear regressions. Or if you want to connect several independent variables, you may refer the kind of polynomial linear regression. Even very recently, I worked one project that related to one industry, where they want to find out what are how the current and voltage fluctuation are related to the IoT's devices. What is the underlying correlation between the current and voltage with the reference to the functionality of the equipment, where I applied the kind of logistic regression. This particular algorithm helped me to identify in which particular pattern there is a chance of power failure, on which particular pattern there is a chance of failure in the machines. That is predicted with the help of this linear or kind of logistic regression that really help you. But however is dependent on the business context. If you want to do the research on the agriculture, again, I think regression is a very good approach, where you want to find out, right, what is the relationship between the crop yield and agriculture productivity, or what is the relationship between the fertilizer and agriculture productivity, where you can plot the kind of regression equation with the help of the mathematical formula like Y equal to mx plus c, where Y and x are the kind of independent and dependent variable, and m is a slope and s is a regression constant, which help you to predict the kind of stuff. But one of the major difference between the classification and regression is that the classification, the class label is a kind of discrete values. Say for example, I want to classify you guys into the two category, active participants and inactive participants is a kind of discrete values. If you want to classify how much you are scoring in the particular end of this workshop is a kind of numeric or the number value, where I refer is a kind of prediction problem rather than the classification problem. When you see the class label of the regression problem, most of the label are in the form of numeric rather than the categorical value. I think this is one kind of difference between these two cases, right? And hope everyone know that unsupervised learning, where the label is not provided to the user. We only know the predictive values without knowing the value for the label or the class label. Again, knowing the class label is very, very challenging in the industry context. Say for example, assume you are the kind of person mostly focus on the primary data collection, where you go to the different place and collect so on so. Now the question is, how do you assign the label for each and every record? Again, it's very, very challenging as in the case of the supervised learning. Sometimes we may invite the kind of domain expert. They are responsible to allocate the kind of label for each and every record. But what is the problem in that case is you need to spend a lot of money, right, in the data annotation, because you need to give the money to each and every expert if they want to allocate the label for each and every record, right? Again, there is a chance of misassignment, but that is a not case in the unsupervised learning because you are going to work only with the predictor, right? So what is the advantage of the unsupervised learning is we are not referring the kind of label and we are only dealing with predictor where we applied a different unsupervised machine learning algorithm and we try to group the object into the several categories according to the similarity. Say for example, with reference to the height, I have to group the list of participants into the two categories, tall and short. Or with reference to the color, I have to categorize the people into the two categories, right? Or with reference to the weight, I have to categorize the people into the several categories. That is very, very interesting, right? Clustering, where the idea is to group the object with reference to the several values. The last one is the reinforcement learning. That also very, very interesting. So major difference between the supervised, unsupervised and reinforcement learning is based on the mechanism of reward and feedback actually. We focus more on getting the collective reward and feedback. Guys, when you see the most of the right current applications, say like autonomous vehicle or driverless vehicle, they focus more on reinforcement learning where you apply the kind of supervised or unsupervised or they are not really good actually. They are totally hopeless, I think. Most of the autonomous vehicle application are right automated vehicle application, they are referring only the reinforcement learning because this particular algorithm are able to identify the pattern in the effective ways. It's based on the principle like reward and right feedback. And I think these are the kind of fundamental, I'm not going to focus more on this particular part and right. So I will give you some example about right underlying algorithm in the machine learning, supervised learning and unsupervised learning. Finally, the reinforcement learning, right? Example for the supervised learning or classification and regressions, unsupervised learning, clustering and association rule mining. Reinforcement learning, most of the autonomous vehicle that I mentioned previously. And here you can see what is the example for the email classification where in this particular case, we try to classify the email into the two categories like normal or spam. But I apply the kind of ML step to identify the email is kind of terrorist or normal email, right? That I got, my paper got accepted in the year 2008 as part of the one of the international conference that is held in the US actually. And I got the financial support from UGC to attend this particular conference in the year 2008. And I attended presented my paper in the particular area, where I applied the kind of ML step to differentiate the email into the two categories, like is a normal or the email of terrorist or kind of suspicious email, right? Similar procedure I have applied. And here you can see that how the regression model is applied in the context of, right, predicting the house price in the particular areas. Say for example, I want to find out what is the house price or apartment price in the next 5 years, where I can able to work with the different regressions. Algorithm help me to find out what is the appropriate price value in the next 5 or 10 years. So which look at various variable like what is the locality of the particular area and what is the type of right house, whether it's a kind of apartment or normal house and what is the size of that particular apartment and what are the other amenities or facilities are provided. So everything is considered as a kind of variable where we try to draw the straight line with the help of the regression equation. If any data point that lie behind or above the straight line, that is considered as outlier and we are not utilizing that particular regression model, right? Again, we try to iterate it with the help of the mathematical procedure that called as R square, right? I expect most of you are what is R square in the context of regression equation. R square is able to determine that how the particular variable are related to the target. Say for example, right, if you work with the area where you want to find out how the electricity utility, right, is determined by the temperature. Say for example, I say that most of the time the utility pattern is only determined by the temperature. But after deploying the kind of regression model, I feel that temperature is not the kind of complete variable that determine the usage of electricity pattern. Right? I also found that there are other kind of variable that also going to determine the utility pattern of the different customer. So later I came to know that there are a lot of variables that are associated in this particular context. So why I'm telling this particular point is don't rely on the particular regression algorithm, particularly linear regression. You try to apply or adopt the different kind of regression model, like how the linear regression applied in this particular context and how the multiple and the kind of polynomial regression are applied in the same context. So you rely most of the cases at the regression, and R squared is one of the fundamental factor that going to decide the quality of any kind of regression model. And here you can see how the particular line is plotted with the help of regression model, and any data point that is far away from the regression model, that is said to be the outlier, and again you need to restructure your regression line accordingly. And this is a very fundamental, and now hope everyone know that most of the recommendation system application, they are using the machine learning algorithm. Say like most of the e-commerce industry like Amazon or Flipkart or other kind of e-commerce industry, they are using the machine learning algorithm to ensure that what are the different item the customer like to purchase, and how the customer profile are changed over the time period, or when will the customer buy item A, what is the probability of buying different item together. So that we can find out with the help of ML algorithms. Even when I did my master at IIM Tiruchirappalli, and most of my stuff are applying the machine learning algorithm in the context of business data rather than applying it on the technological problem. If time permit, I will explain the rest of the part and how the kind of ML stuff is applied on the different areas in the management context. And here in this particular slide, you can see that what is the difference between the classification and regressions in the context of machine learning, where in the case of the classification, the output are either pass or fail, or since it's a kind of binary 0 or 1. But in the case of the regression, the output is kind of numerical value, say like 90 or 100 or whatever it is number, and here you can see what is the comparison between the supervised and unsupervised learning. As in the case of the supervised learning, we have the predictor and target, then we apply the ML algorithm on it. But in the case of unsupervised learning, we are only dealing with predictor without any target values, And when you talk about the performance evaluation for the quality of any machine learning algorithm, the people talk about the machine learning data set that is called as the training and test data, Hope everyone know what is the training data and test data and how to make the split up among the training and test data, Industry standard is that 70% of the data may be utilized for the training and remaining 30% may be utilizing for the testing purpose, this is a case where you have seen that there are three variables, The first variable is the label, and there are another two variables are gender and age. This gender and age are referred as the kind of predictive variable, and label is referred as the target or the class label. So obviously we understand that is a label data set for the classification problem or the supervised learning, This is another example where we can apply the kind of clustering algorithm, where you can see the two variable gender and age, where gender is the first predictor and age is another predictor, but we are not referring any class label in this particular context. And I think this was a story. Supervised learning, we learn with the help of supervisor, maybe the teacher, and as in the case of the unsupervised learning, we have to perform the learning without a supervisor or teacher or expert. But as in the case of the reinforcement learning, we have to work in the broad way, where we have the capability to accept both the reward and punishment, So this kind of learning is said to be the reinforcement learning. Assume you are developing the application for autonomous vehicle, where you have to refer the reinforcement learning, So where you can see that there is obstacle in front of the vehicle. So what is really required for the vehicle is that the algorithm need to ensure that what type of obstacle is it? Is it the kind of human or car or pedestrian or something else? I think it's really challenging to the algorithm to determine what type of algorithm, what type of object is it. So that is the reason why they are referring the kind of reinforcement learning rather than supervised or unsupervised, And coming back to other part of this particular presentations, and I'm going to talk about one of the interesting part on this part, machine learning, and guys, this is the area that where I focus more, right? And right, yes, this is the area where I focus more during my pursue PhD, right? So this is the decision tree where you can see the kind of difficulties, right? What is the problem here is you can see the equal number of class label for both the positive and negative example. So this is represents a kind of majority voting failure, and as in the case of the decision tree. So as part of my PhD work, I have provided the kind of solution to overcome this particular problem. This cited in the Wikipedia as one of the most significant contribution in the field of data mining and machine learning research in the year 2009 actually. And I have did another contribution where I mentioned previously that related to the NP plus, where I resolved some kind of problem in the navigation classifier to handle the problem of right equal probability for the any given test case. That also very interesting, right? And I'm going to talk about more on responsible artificial intelligence, because when you see the industry, they focus more on how to develop the kind of right effective data mining or ML or artificial intelligence model or algorithm. But at the same time, you should focus more on right. Assume you are going to deploy any AI algorithm on the model. Now the question comes, what kind of ethical principle behind this particular model or AML algorithm? That is really very challenging questions, right? So when you see the ethical principle that applicable to the any AI model, basically there are four principle underlying principle. So these are transparent and secure and ethical and interpretability. So here you can see the example where you can see the kind of failure that is caused by the AI system. Say for example, what is the problem in this particular context is the original object are misclassified by the AI algorithm, and wrong object may be classified as the correct object. Say for example, there is an image which I talk about the COVID-19. If you apply the kind of ML algorithm can classify the original COVID-19 image into the no COVID-19, and no COVID-19 image may be classified as the original image. This is referred as the failure in the context of explainable artificial intelligence. Now the question is, who is responsible for that? Whether the developer of particular model or the person who collected the data or somebody else, right? When you see the countries like India, there is no strategical framework which help you to identify what are all the strategical framework or what are all the governance structure that should be followed while developing any ML or AI model for your applications, right? There is no specific approach is available. Madam, are you able to see the screen?
Yes, sir, I can able to see this.
Okay, great, madam, good. And in this particular example, you are seeing that there are a lot of right sensitive issues that are associated with ML algorithms. Say for example, what happened in the US in the year 2018 is there is a group of persons who are part of the Senate, US Senate, are classified as a criminal by one of the AI ML model. And accordingly, the case was right formulated in the US code, right? What happened is most of the positive cases are classified as a negative by the algorithm. So later they came to know that the problem is due to the person who deals with a particular data set. They, while allocating the label for the particular data set, the domain expert I allocate the wrong label for the original data set and right original value for the wrong data set. That is the kind of misinterpretations. Again, there are a lot of problem arise after the 2018. The case went to the US court and the departmental proceeding was initiated. So they thought of developing the kind of strategical framework to ensure what kind of ethical principle to be followed in this particular context, because there is no problem in the AI algorithm, but there is a problem in the data. Those who are dealing with the data, they have to do the kind of modification on it. Later, the kind of developer, they have to apply the different ML model. Obviously, we are getting the different result, right? That is a very challenging part. And in this particular example, you can very recently came to know that most of the industry, they are using the AI and ML model as a tool to pick the right candidates for the industries, right? Even Amazon, they eliminated the kind of woman candidate very recently while performing the kind of recruitment process. What happened is all the woman candidates are eliminated by the particular AAML model, which make the kind of very sensitive to the industry. Again, the responsible or ethical artificial intelligence was created. Even you guys, you know that the government also formulated the kind of strategies very recently by the Ministry of Information and Communication Technology, MITI. They have formulated the kind of strategies which help you to find out what are the framework to be followed while deploying any AI model to the industries. Right? That is talk about different scenarios. And again, driverless vehicle, people talk about the Tesla. 2 persons are killed, right, by this particular vehicle. Again, there is a question comes whether the driver is responsible or the person developed by this particular algorithms. I'm not saying that the machine learning solve all kind of problem either in the domain of healthcare or education or agriculture, so on so. However, the ability to extract the hidden patterns and trend from the large quantity of data, that is very, very important, right? So I hope that there is a lot of opportunity in the domain of machine learning and generative AI, at least for the next 20 years. But when you see the difference between Gen AI and with other terminology, we can see that the generative AI is the subset of the deep learning, right? This is not part of, this is not a subset of ML. Again, the Gen AI is considered as a subset of deep learning, where we can able to generate different image or text, audio, video, so on. So I think it's a very powerful tool in the context of both the technology as well as management and business application. Even I came to know that most of the IIMs, they have framed the syllabus in the area of generative AI. They want to see that how the generative AI transform entire business industry and in terms of generating revenues or profit and other dimensions. And one more vertical application of the generative AI is education. I think this is the part of this particular workshop. I hope there are a lot of opportunity, but on the other side, there are a lot of consequences while you apply the generative AI in the domain of educations, right? Because we are not able to differentiate that which content is generated by AI system and which content is generated by the humans, right? Now, that is why the people are talking about plagiarisms, right? Again, is a very, very challenging in the academia. So my personal point is that if you want to deploy the generative AI in the context of educational framework, you should be able to follow the kind of strategical framework that suggested by the government. Otherwise, you may face a lot of consequences after deploying your model on it. Even very recently, I have submitted one proposal to the DSC, which I talk about what happened if you are not following the kind of framework after deploying the AML stuff or the model to the different industries. That is very, very sensitive. And one more interesting application of generative AI is climate applications. Why is interesting is we can able to generate the synthetic data for the future climate scenarios. That is not possible with the help of the conventional ML or deep learning or even data mining models. And finally, the hard work is an investment, is not expense. Hard work is an investment, not expense. If time permit, I will ready to talk about the 2 different projects where I applied the kind of AML stuffs. One project is related to the people analytics, that is part of the behavioral dynamics, where I applied the kind of ML model to find out how the people behavior are dynamically changing. That is the one part, and this related to how the data mining ML are applied in the domain of behavior analytics. And I have another presentation which I talk about how the employee attrition problem is dealt by the different ML algorithm or ML stuffs. And where you can see that how I perform the kind of data collections and what is my objectives and what is my research questions and what are all my hypotheses, right? Because hypotheses that play a major role in the context of machine learning research. Even though the hypothesis is part of statistics, but sometime in the context of machine learning, we need to refer both null and alternate hypothesis. That is basically referred as statistical machine learning. That is another area, as in the case of AI and ML. There is a separate area which is referred as statistical ML. And I also talk about what is the significance and scope of this particular studies and what is my proposed approach and what are all my variable or data set and what is my machine learning framework, where I talk about what is the training data and what is my model, what is my algorithm choice and how the model is generated and what kind of prediction I am doing actually. So this particular problem is focused on, I want to find out what is the attrition level by the different employee. Say for example, assume you are the manager of the particular company or organization, you want to find out whether the employee will leave from the organizations. Where the challenging part is that what are the variables that lead to the problem of employee attrition. Say for example, if you ask me the question that what are the factors that related to you to leave from any particular organization, I say salary is not a matter for me, but I expect the kind of self-respect, right? My variable may be the respect, and if you ask the same question to the Aarti madam, madam maybe suggest the salary is one of the variable. If I ask another participant, he may suggest distance is a major problem. And if you ask the same question to another person, he may suggest that, right, no growth for the opportunity. So what is the problem in this particular context is variable are not the kind of discrete values, the continuous. When you deploy the ML model on this particular problem, what is the problem is the data are highly related, where it's very difficult to understand the underlying principle, right? Even I found that the accuracy is not up to the expected level. I reached the accuracy of 40%, even when I applied the kind of ensemble algorithm on this particular data sets. But what I suggest is that you have to download the data from the repository, where you can get the data from the Gaggle, and data is referred as IBM employee attrition data set. That is a kind of secondary data analysis. Otherwise, you have to perform the primary data analysis, where you have to develop your own format and send the format to the employee, those who are working in the different organization, ask them what are the variables are related to them for attrition or leave from the organization, and you have to deploy the kind of ML algorithm on it. The algorithm help you to ensure that what are all the most contributing variable and what are all the less contributing variable and why the particular employees are leaving from the organization. If you are able to identify all the reason right before the particular event is occurred in the organization, obviously, right, there are a lot of advantages for the organization. One is no need to perform the kind of interview and it's ready the burden of HR and manager and so on. So, right, this is a right how I applied different Python stuff and where I applied the logistic regression, KNN, random forest and gradient boosting and database. Here you can see what is my confusion matrices look like, and I found that right gradient posting is most powerful algorithm as in the case of right identifying the correct reason for the attrition, and while rappelling the kind of accuracy, I found that database is dominating the other algorithm, right? And these are the various factors that decide while employees leaving from the organization. One is the career choice, and they are not satisfied the work environment or benefit or salaries and management related factor or sometimes work life related personal life, and these are the kind of major factor. Maybe the career choices or work environment or salary and benefit related factor, and after analyzing it with the help of ML stuff, I came to know that these are the most dominating factor. The first variable is the career planning, and appraisal system is not good, and they have the health issues or they have the kind of work-life balance or job profit not meeting the expectation and remuneration also. And they also right found that lack of responsibility and ownership is really missing, or there is no motivation at all and no promotion and opportunities, and sometimes no opportunity for the training and development and lack of challenges and opportunity. These are variables that I find it by deploying the kind of ML algorithm in this particular data sets. And what is the major problem in the context is variables are highly related. So you try to develop the kind of effective ML algorithm, obviously you are getting very good result in this particular contest. These are all my finding, and these are all the factors I consider: monetary benefit, personal relationship, employee engagement, and so on. So based on that, I have provided the kind of recommendation to the users, and these are all my questionnaires. My questionnaires is something like: what are the main factor contribute to the attritions in Indian academic institution, considering your experience? And you can see there are a lot of other questions in this particular contest, right, which talk about environment and salary and other benefit and other related factor at all. And I would like to thank the King's College of Engineering, both coordinator and convener of CSG department, for providing me an opportunity to interact with you. And this is a time for questions, and really happy to answer it actually. Any question from the audience? But the point is that the technology is ever changing, right? In the era of computer science, the technology is ever changing, lot of transformations. Even previously, I studied most of the algorithm in the area of ML and data mining and data science. But now the scenario is different actually. You want to study generative AI because most of the current application rely, right, mostly on generative AI. You should possess the kind of stuff in this particular area. That is the expectation not only from the industry and academia as well. Right? You have to refer a lot of forum and material that talk about the generative artificial intelligence. But basically, you have the thorough knowledge in the underlying area like artificial neural network, which is a very, very essential if you want to become the master in this particular domains. Right? Any questions? And professors, if you want to do kind of collaborative research where you look for any collaborator, and if you want to work in the different vertical area of machine learning or generative AI, I am really happy to work with you as one of the collaborator. And I am currently working in the different vertical area of ML and generative AI. And the first application that I am working is I am developing a kind of new machine learning algorithms, which is similar to the traditional ML stuffs. That is the one work that I am doing presently. And my second work is on how to apply the different ML stuff to the agriculture applications. So particularly I am interested on, right, crop yield prediction with reference to the several agriculture variable with the help of regressions. That is the second area I am working. The third area is I am working in the area of the climate change, where I want to generate the kind of synthetic data with the help of GAN model, right, for the next 25 years. And I want to classify the several region or part of the India into the several category like mild or severe or average with the help of GAN model. That is the third work I am working presently. And the fourth work I am focused more on how to develop the kind of chatbot for the old age people, which really able to capture the kind of dialogue between the developer and old age person. So which try to capture the kind of emotional intelligence from the old age person. So which really obviously require the kind of stuff from both NLP and generative AI. That is the fourth area I am working. And if last area I am working somehow on the area of healthcare analytics, right? Where I try to apply the different generative AI and ML stuff on it. If you are the kind of person who are looking for the collaborators in this particular area, or if you want to work it, I am really ready to work with you. I am really happy actually.
Thank you, sir. You had a very great session and a very expanded session. We had a very good knowledge in this particular basics concepts. As usual, you rocked, sir. And some of us were willing to do a collaborative work. I hope so. And thank you for this.
Ma'am,
Thank you for the session.
I have a query with sir, ma'am.
Yes, please. Yes, please, Geeta, ma'am.
Yeah, ma'am. Thank you, ma'am. Good evening, sir.
Good evening, ma'am. Good evening, ma'am.
Yeah. Sir, being a beginner in ML, like I'm currently working in LPU, Lovely Professional University. So
Okay.
I've been teaching data mining there for
Okay,
which there was a subject where they were using a tool of rapid miner,
okay,
where we were just using certain classification like name based decision trees and certain basic models with data mining for rapid miner.
okay, ma'am.
But sir, if I wish to pursue my research in ML, can you please recommend me a tool which I can use for performing of my algorithms?
Yes, ma'am, exactly right. Well, I think that is a very great question actually. And Asim, you are the kind of expert if you want to do the research where you
Yes,
focus more on analysis part rather than deploying or developing your own model.
yes, sir.
I think in that case, Rabbit Miner is one of the best choice. But if you want to develop the kind of prototypes or working model, so according to the industry requirement, where I feel Rabbit Miner is not a good choice. Not only the Rabbit Miner, Vega or Orange or RTool or MATLAB also. So I think the Python is a good tool in that particular context because when you see the industry scenario, the industry says almost the Python displays all the conventional programming language as in the case of the data science and ML research. So I recommend you to work with a different Python application, particularly scikit-learn, where you can see the variety of machine learning stuff like algorithm for the classification, clustering, association rule mining, and feature selection. That is really helpful for you.
Thank you, sir. Okay, Python. I will try my learning my models. I tried with Google Colab, but there are certain AI models like which are automatically writing the code in Google Colab.
Yes, madam. Yes,
Yeah, but Python. Thank you so much for suggesting. Will try my models in Python.
that is good, madam. Because most of the AI algorithm are kind of black box method, right?
Yes.
So we are able to see how the particular algorithm or the result is generated without understanding the underlying principle. Assume we are working in the Rabbit miner, we are not able to understand what is the underlying principle of each and every machine learning
Yes, yes.
algorithm. That is
These are
very, very
just drag
essential for
and
the
drop
new
options
researchers,
are there.
right?
Yes.
You try to understand what is the mathematical principle behind each and every ML algorithm. That is very, very, really essential for any ML expert actually.
Yes, sir. Thank you, sir. Yeah, thank you, sir.
Thank you very much, ma'am. Any questions, ma'am?
Thank you, sir. Thank you for your insightful and provoking session. I'm sure all our participants are deeply engaged in understanding the fascinating world of machine learning. We now, if the participants have any questions or thoughts, feel to drop the chat box or unmute yourselves to ask your questions, please. Okay, as we near to the end of this today's session, I must say this has been an enriching experience. Dr. Balamurugan has brilliantly unveiled the complexities of machine learning and made it accessible for all on behalf of King's College of Engineering and IEEE STB 16221. We extend our heartfelt gratitude to you, sir, for sharing your expertise and inspiring us. As a big thank you to all the participants for your engaging, and today's session has been another stepping towards mastering AI and machine learning. We look forward to see you all again for day 3. Thank you for the most, sir.
Thank you very much, madam, for the opportunities. Hope everyone enjoyed the sessions.
Yes, sir. We learned something from the session. Thank you, sir. Thank you, sir. Thank you
Thanks a
for the
lot.
short notice you accept our invitation, sir.